In this video, we will cover the central difference method. The key question that the central difference method asks is that if we know ui and ui minus 1, can we calculate ui plus 1 from an average velocity estimate? So the picture on the left shows what this looks like in a conceptual sense. So in this case, we know our current u, we know our previous u, and we are trying to find the next u. And the key assumption here is that if somehow we can estimate this central velocity here, we can use it to project from ti minus 1 to ti plus 1. In a discrete sense, what we actually have is what's shown on the right side. So again, we know the displacement at ti minus 1, we know the displacement at ti. We are trying to find the displacement at ti plus 1. And so the way this method approaches it is that we calculate an average velocity between ti minus 1 and ti, which we call u dot a, and we calculate an average velocity between ti and ti plus 1, which we call ub, and then we calculate finally a average velocity between ti minus 1 and ti plus 1, which is what we call the u dot I. And it's this u dot I that we can use to project forward. Okay, so u dot A is calculated as an average velocity simply by dividing the two displacements by delta t, which you see here. This is known. UB is calculated in the same way, but using an unknown quantity, right? Which would be a ui plus 1. Using those two values of u dot A and u dot B, we can take it one step further and make estimates for the values of u dot I, the velocity at I, and u double dot I, the acceleration at I. So for u dot I, we can use the average of u dot A and u dot B to calculate that quantity. And so that simplifies to the equation you see here, where we have a known quantity ui minus 1 and an unknown quantity ui plus 1. Of course, at this point, u dot I is also unknown. All right, so we have two unknowns, so we need another equation. So we also calculate u double dot I, and this is simply done as the average acceleration from ti minus 1 to ti plus 1. Okay, so we take the difference in velocity and then divide by delta t. This simplifies to this quantity here, and we have essentially the same unknowns and knowns. So ui minus 1 is known, ui is also known, ui plus 1 is unknown, and ui double dot is also unknown. So we notice that at the end of this, we have two equations and three unknowns, so we need an extra equation. This is where the equation of motion comes in as usual. So we're simply going to take the values for u double dot I and u dot I and plug them into our discretized equation of motion, which you see here. All right, and by plugging those values in, we get the form that you see right below. Notice the terms in the brackets correspond to our u double dot I and our u dot I. From this point forward, it's simply algebra, so we're going to try to isolate ui plus 1. Notice that now the equation is in terms of all known quantities except for ui plus 1. Okay, this is our only unknown. Everything else is known. We know the forces, we know the velocity we know the displacement 2 steps before, we know the displacement at our current step. And everything else is either a sampling interval or a system property which is constant. So we can actually label some of these constant values. So we're going to call this term here k hat. We're going to call this term here a, and this one here b. And then we're going to introduce another notation just to make things easier. We're going to call this whole term on the right side or p hat I. Okay, this of course will change with each iteration, but this makes the final formulation a lot easier to write. So what we say is ui plus 1 is equal to p hat I divided by k hat. So our final algorithm looks something like this. This is something that you can code directly. We start with some initial calculations that are done only once. This solves for our initial acceleration, our velocity before we even start, and the values for k, a, and b. All right, this is done once, and then we iterate through each I, where we calculate the p hat I, and then we solve for ui plus 1 using that formula that we defined in the previous slide. If needed, the calculations for velocity and acceleration are actually pretty straightforward based on the initial calculations that we did.